Okay, we want to continue in section 3.5. We're at part 2 video. And remember, we worked 4 examples last time, and you actually should already have this whole problem written down in your notes because I told you to copy it. So remember what the instructions was to these problems. This is the 5th example. What were we looking for? Find the equation of the line. So here's what we're looking for in this problem. We're looking for the equation of the line that goes through these 2 points right here. Now, I told you to find the equation of a line. I told you that there's 2 things that you have to know. Number 1, a point on the line. We know a point. Matter of fact, we know 2 points. But you also have to know the slope of the line. And then we use the point slope formula. Well, I don't know the slope. I'm not told the slope. But we're given 2 ordered pairs. Well, now think, have we at any point ever found the slope of a line when we know 2 ordered pairs? Yes. If you look back at the end of the very last problem we did, video, in section 3.4, we did that. Remember, the way you find the slope of a line that passes through 2 points, you call the first point x1, y1, you call the second point x2, y2, and you use the slope formula. So that's where this comes from. Now, I'm not going to labor here very long because we've already done that. We did that in 3 examples earlier. All right, so now I have the slope. So now what I want to do is use the point slope formula. Now, one of the common questions asked is typically this. Mr. Strainer, when you use the point slope formula, I know this is the slope, but which point do we use? It doesn't matter. The reason it doesn't matter is your line goes through both of these points. However, I would suggest that you use the first point simply because you've already labeled it x1, y1, and that's what's in your point slope formula. So I always use just the very first one. But if you use this one, you'll get the exact same answer. All right, so I've got y minus y1 is 2 equals m, which is 3/5, which you just found, times x minus, and then x1 is -3. Double negatives gives you a positive. So I just changed that to a positive. Now remember, we said write our answer in 2 ways. Slope-intercept form and standard form. Okay? So what I'm going to do is distribute first. 3/5 times x is 3/5 x. 3/5 times 3/1. Numerator times numerator, denominator times denominator. Now add the 2 back across. And when I do, it becomes plus 2. And then you can add these 2 together, but you can't add it with this because this has an x with it. But you can add these 2. Remember the way you do that, either use your calculator or write this 2/1. The common denominator is 5. So this would be 9/5 plus 10/5, which is 19/5. So all I did was got a common denominator and added those 2 fractions together. All right, this is your answer if you're asked to give it in slope-intercept form. I also want to give it to you in standard form. All right, so let's do that. What does standard form mean? It means get the x's and y's on one side, leave the number on the other. So what I'm going to do here is I'm going to bring this 3/5 x, I'm going to bring it back to the left side. When I do, it becomes negative 3/5 x plus y equals 19/5. Now, this problem, to finish it, there's 2 things we need to do. First, remember I said in the last example, standard form doesn't like the first term being negative. So how did we deal with that before? Multiply through by -1. When I do, that just essentially changes all of the signs. Now, here's something else that standard form doesn't like. Standard form doesn't like the first term being negative, but it doesn't like the fractions in the problem. Well, we've talked about clearing fractions before. How can you get rid of fractions in an equation? We did that on your midterm exam. Multiply through by your common denominator. So what I'm going to do to get rid of these dividing 5s is multiply by 5. When you multiply by 5, it has to be by every one of these. 5 by this one, 5 by this one, 5 by that one. It's like distributive property. When you multiply 3 by 5, 5 times the 3/5 x is just 3x. 5 times the y is 5y. And then 5 times the 19/5, the 5's cancel and leaves the minus 19. Now, I know that's no fun to do, but you certainly have to agree that that looks a whole lot better than that right up there. So get rid of all your get rid of that front negative, and get rid of all your fractions in standard form. And you say, well, wait a minute, Mr. Reiner, if standard form doesn't like the fractions, why do we leave the fractions in the slope-intercept form? And here's the answer to that. You can't get rid of fractions in slope-intercept form, and here's why. You say, well, I want to get rid of these dividing 5, so multiply 3 by 5. If you do that, you multiply this by 5, this by 5, but you also have to multiply this one by 5. When you multiply this one by 5, it makes it 5y. Well, if it makes it 5y, that's not slope-intercept form, because slope-intercept form means get the y by itself. So we don't get rid of the fractions if there are any. We don't get rid of the fractions in the slope-intercept form, but we do in the standard form. Okay, so that's part E. Now, in just a minute, we're going to do part F. But before we do that, I need to make sure that you understand a couple of things. So, I want you to write down 2 notes. So we're going to run a little rabbit here for a few minutes, and then we're going to come back and do a F and a G. So we're not finished with finding the equation of a line, but I got to give you this first. Take these 2 notes down. Here's the first note. If 2 lines are parallel, their slopes are equal. Now the second part of the note. If 2 lines are perpendicular, their slopes are negative reciprocals. reciprocals. Negative reciprocals. Okay, so let's talk about that, and then I'll tie it back in with find the equation. So we're going to do F in just a few minutes. All right, first let's talk about the obvious. If 2 lines are parallel, first remember in geometry, the word parallel means that the lines run side by side, like this, or like this, or like that, or maybe like that. That's what parallel means. It means they run at the same angle. So the fact that if 2 lines are parallel, their slopes are equal, that shouldn't shock you. So for instance, and you don't have to write this down because it is obvious. Let's suppose I told you that I had 2 lines that were parallel. And let's suppose that I also told you that the slope of the first line was 4. Well, if these 2 lines, if you had 2 lines that were parallel, if the slope of the first line, that's what M1 means, slope of the first line. If the slope of the first line was 4, what would the slope of the next line be? Obviously, 4. If the slope of one line is 0, which means it's a horizontal line, by the way, slope of the other one's horizontal. Slope of the other one's 0, I'm sorry. If the slope of one line's undefined, which means it's a vertical line, just a x, slope of the other one will be undefined. If slope of one of them is negative 3/5, Slope of the other is negative 3/5. So that's a pretty obvious fact. Now let's talk about perpendicular lines. Now, before we talk about that, let me give you kind of a visual. So if I had a line that looked maybe something like this, what would the line that is perpendicular look like? It would be something like that. If you remember from geometry means that two lines are perpendicular if they intersect to make four 90-degree angles. Now, we're not going to even get that mathematical with it. Two lines are perpendicular if it makes a perfect T or a perfect cross. Now, what does it say about these two lines? It says the two lines are perpendicular if their slopes are negative reciprocals. Now, what does that mean? The word negative reciprocal means two things. First thing it means is the word negatives means that they're opposite in sign, but that's not all. The word reciprocal means that the numbers are flipped. So, if I told you two lines were perpendicular, and I told you the first line had a slope of 7, what would the second line have a slope of? The negative reciprocal. So, what would it be then? Negative 7? No, it would not be negative 7. It would be negative 1/7. 7, and then change the sign and flip it, negative 1/7. So, if one of them was negative 1/8, if they're perpendicular, now you have to be told that, then the other one would be a positive 8/1. If one of them had a slope of negative 3/5, the other one would be a positive 5/3. If one of them had a slope of 5/8, the other one would be a negative 8/5. So that's what we mean by perpendicular lines, and that's what we mean by negative reciprocals of each other. The only two that's weird with negative reciprocals are these two. This one. So let's think about it. If the slope of my first line is 0, what does that mean graphically? It means it looks like this. It's a horizontal line. So, what is perpendicular, up top, what is perpendicular to a horizontal line, a vertical line? Now, what kind of slope does a vertical line have? It's undefined. So 0 and undefined are negative reciprocals of each other because one's horizontal, one's vertical. Now, if the slope of the first one was undefined, the slope of the second one then be 0. So the negative reciprocal of 0 is undefined. The negative reciprocal of undefined is 0. Okay. So we're back to example, I believe it's F. Example F. All right, write this down. Find the equation of the line that passes through the point 5, -2, and is parallel to the line, and then write this down. 2x plus 3y equal 9. Okay, so here's what we're going to do. What are we looking for? Find the equation. What two things do we have to find in order to get the equation of a line? We have to know a point on the line. We do. and we have to know the slope of our line. We don't. We're not told the slope, and I can't find it with just one single point. However, what do we know about the line that we are looking for? It is, what's this word right here? It is parallel to this line. Now wait a minute. If my line is parallel to this line, what does that mean about their slopes? It means that they're the same. So, if I can get the slope of this line, won't that be the slope of my line? Yes, because they're parallel. And then if I can get the slope, then I can use the point slope formula to finish it. So, how do we do this? Well, let's see. Let's get the slope of this line. How do we do it? If you'll remember, we talked about putting an equation of a line in slope-intercept form. So here's what I'm about to do. I'm about to find the slope of this line right here. Once again, why? Because my line is parallel to this one, and it will have the same slope. So how do I put this in slope-intercept form? First, move the 2x across. When I do, it becomes 3y equal negative 2x plus 9. Then divide 3 by 3 to solve for y. Now when I do that, this is in slope-intercept form. So the slope of this line is negative 2/3. Now what do we know about this line and my line? We know that they are what? Parallel. So my line will have the same slope as this one. So if this is a negative 2/3 slope, then my slope over here, the slope I'm going to use, is also negative 2/3. Now, take this slope and this point and finish the problem. So what we're going to do, call this x1, y1, call this m. And then we're going to plug it straight into the point slope formula. Pause the video now and copy this. Okay, I'm assuming you paused the video. Now we said y minus y1 is negative 2. Double negative is going to give me a positive. Equals m, which is negative 2/3, times x minus, and then x1 is 5. We're going to distribute. Negative 2/3 times x is negative 2/3 x. Negative times a negative is a positive. 2 times 5 is 10. 3 times 1 is 3. Then I'm going to subtract the 2 over and get a common denominator, or use your calculator to subtract these two numbers to get this. That's in slope-intercept form. I'm going to do this one more time with you. What would we do if we said standard form? Well, we would take this and move it back across. So when I take it and move it back across, that's what I would get. But we can't leave fractions in the standard form. So when I multiply by 3, when I multiply this by 3, the 3's cancel and leaves 2x. When I multiply this by 3, it leaves 3y. And when you multiply 4/3 by 3, the 3's cancel and just leaves 4. Okay, now write this down. This is the next example. This is example G. Here's the problem. Rework the previous problem. Rework the previous problem using the word perpendicular. Now, I'm not going to go all the way through this because once you do this first part, the rest of it's the same. But let me just show you. So in other words, what if we do this same problem again, this one, but change that word to perpendicular? Will it change my point? No, it will not. Will it change what the slope of this line is? No, it will not. What it will change is the slope of the line that I use for my line. Now, what did we find the slope of this line to be? Well, we did it just a minute ago. Just to show you again the work. The slope of this line was negative 2/3. Now, if my line is perpendicular to this one, do I use that exact same slope? No. I use the negative reciprocal slope. So what is the negative reciprocal slope of negative 2/3? It would be positive 3/2. It'd be a positive 3/2. Now, we're not finished. So what you'd have to do to finish this problem, here's your point, here's your slope now. And then you go through and work it just like we did the last example. You're just not using negative 2/3, you're using positive 3/2. So this, the x1 goes here, the y1 goes here, the slope goes there, and go through and put it in slope-intercept form. Then you can put it in standard form. So the work is exactly the same. The only thing you have to remember is, if it says parallel, you use the same slope. If it says perpendicular, you have to change the sign and flip it. And then you use the point slope formula in either case. Okay? All right, 2 more examples, and these are going to go a lot quicker. Write this one down. Find the equation of the line that passes through the point negative 7, 4 and is perpendicular to the line x equals 6. Now, let me show you why this one goes fast. All right, perpendicular. Find the equation. What 2 things do we have to know? A point and the slope. Do we have a point? Yes, we do. Do we have a slope? No. But we know that my slope is perpendicular to this. Now, look at this. X equals 3. Just a x. If it has just a x in it, what does that tell you about the graph of that line? If it's just a x, it's vertical. Okay, if it's vertical and my line is perpendicular to the vertical line, then my line would be what? Horizontal. Now, if my line is horizontal, I don't have to use the point slope formula. And the reason is, if my line is horizontal, my line will have just a y in it. So my answer is going to be y equals some number. And that number is whatever your y number in your ordered pair is. So it's y equal 4. Now, last comment, and I'm done. You can pause the video to copy this. Okay, last comment. If this word right here had not been perpendicular, so pay attention when you read. If this had said parallel, how would that change things? Well, wouldn't this still be a vertical line? Yes. But if this is parallel now, my line is vertical. So if my line is vertical, the equation will have just an x in it. So my line would be x equals some number. And the ordered pair, it would be x equal -7. So if that word had been parallel, it would be x equal, but it'd be -7 because that's what the x is in that number, in that ordered pair. Okay, this completes section 2.5 videos.